Hello, I am AYUSH Srivastava. I got an All India rank of 8637 in JEE Advanced 2013. I scored 216 out of 360 in JEE Main 2013, and I have done my BTech in Production and Industrial Engineering from NEET in 2017. For my demo class, I have chosen the topic of Coordinate Geometry Overview, Locus and Straight Lines. So let's get started with it. Coordinate geometry helps us to define the location of a point in a 2D space. We'll be studying two types of coordinates. First is Cartesian coordinates, second is polar coordinates. In Cartesian coordinates, to define the location of a point, we need two things. First is the origin, second is the coordinate axis. Further, inside the Cartesian coordinate system, there are two coordinate systems. First is rectangular coordinate system, second is oblique coordinate system. In rectangular coordinate system, the x and y axis intersect each other at the origin. This is the origin at an angle of 90 degrees. In oblique coordinate system, x and y axis intersect each other at the origin but an angle which is not 90 degrees. So hence the name oblique coordinate system. Now for an example, if you want to define the location of a point P in rectangular coordinate system, then say this is point P and its coordinates are x, y. So the value of the x coordinate is the perpendicular distance of the point from the y-axis, and value of the y-coordinate is its perpendicular distance from the x-axis. Hence the coordinates become equal to x, y. To define the location of a point in polar coordinates, we need two things. First is the distance of the point from the origin, r, and second the angle that the line joining the origin and the point makes with the positive x-axis. For example, if we take a point x, y like this, its distance r from the origin and this angle being theta, then using simple trigonometry we can say that this distance is r sin theta and this distance is r cos theta. So we can define the location of x, y as x is equal to r cos theta and y is equal to r sin theta. As discussed in the polar coordinate system, x is equal to r cos theta, y is equal to r sin theta. Dividing this by this, we can see that y upon x is equal to tan theta. Now let's solve a question based on this concept. The question says that the Cartesian coordinates of a point are root 3, 1, and we need to find its polar coordinates. So using this information, we can plot this point on x and y axis, moving root 3 distance along x axis and 1 along y axis, we reach this point which is root 3, 1. And plotting theta and r here, using this relation we can say that tan theta is equal to opposite upon base, which is 1 upon root 3, and this gives us as theta is equal to pi by 6 radians. Now since this is a right angle triangle, we can apply Pythagoras theorem in this triangle, which will give us r square is equal to 1 square plus root 3 square, which in turn will give us r is equal to root 4, and this implies that r is equal to root 2. So our answer is r is equal to 2 and theta is equal to pi by 6, and this answer matches this. So this is our answer. So the locus of a point is defined as the curve traced by a moving point under some given geometrical conditions. So inside coordinate geometry, the topics that are there in our syllabus are straight line, circles, parabola, ellipse and hyperbola, and all these are locus of a moving point. So there are some steps to find the locus of a point. The first step is to draw a rough sketch of the moving point and then mark the moving point as h, k. Step 2 is to apply the given conditions in the question on the point P, and the final step is to replace h, k with x, y to get the final equation of locus. Distance between 2 points with coordinates x1, y1 and x2, y2 is given by this formula, root of x2 minus x1 whole square plus y2 minus y1 whole square. We have studied this in 9th and 10th standard, and its proof is fairly easy. It's given here. I plotted 2 points with coordinates x1, y1 and x2, y2, and we finally reach to the point that we get a triangle with sides x2 minus x1 whole square and x2 minus x1 and y2 minus y1, and the hypotenuse is d. So using Pythagoras theorem in this small triangle, we reach to this equation, which is root of this distance square plus root of this distance square. This gives us d. So let's solve a question on locus. The question says that find the locus of a point whose distance from origin is always equal to 2. Let's go step by step. The first step says that draw a rough sketch of the moving point. So let's draw the coordinate axis as x and y, and then we have to apply the given conditions of the question. So the condition says that the distance of the point from origin is always 2. This is origin, so this distance is 2, and this is h, k, and this distance always remains 2. So if I plot it like this, can we see that this distance from origin always remains 2, right? Let's try to put this in the form of an equation. So the distance between this point and origin is 2. So using the distance formula, we can say that x2 minus x1 plus y2 minus y1 whole square is equal to 2. If I square it both sides, then h square plus k square is equal to 4. And if I replace write the third step here, replace h comma k with x comma y, then x square plus y square is equal to 4. This is our required locus. Let's talk about the slope of a line joining 2 points x1 comma y1 and x2 comma y2. Slope is also known as gradient. So these are 2 points x1 comma y1 and x2 comma y2. And we have formed a right triangle connecting these 2 points and this point, and we can see that this distance, which is b, equals to y2 minus y1, and this distance a equals to x2 minus x1. To understand it in a layman language, we can say that slope is how much you are traveling in the y direction as compared to your travel in x direction. So if you are traveling more in y direction compared to a little travel in x direction, then your slope will be higher. But if you are traveling less in y direction compared to your last travel in x direction, then your slope would be smaller. This can be expressed as tan theta, which is also equal to the slope, and tan theta is equal to slope is equal to b by a is equal to y2 minus y1 upon x2 minus x1. Yeah, so after all this discussion, let's see what a straight line is. So straight line can be defined as locus of a point such that its slope is always constant. So I've taken 2 examples here. In the first example, I have drawn a curve with a blue ink, and I've drawn tangents at 3 different points. At this point, at this point, and at this point, and I can see that the inclination of these tangents are different. This theta is different than this theta, and this theta is different than this theta. And the slope is, as we had defined earlier, slope is defined as tan of theta. So this tan theta is different than this tan theta is different than this tan theta. That means that the slope is changing for this curve. And just now we defined that a straight line is the locus of a point such that its slope remains constant, so that we conclude that this is not a straight line. And similarly, in this example, I have drawn a curve like this, and I can see that this theta, and this theta are all same. That means the slope at this point is equal to slope at this point is equal to slope at this point. So here the slope remains constant throughout the curve. Hence, we can say that this is a straight line. Now let's talk about equation of a line in different forms. The first form is point slope form. For this, we need 2 information. The first one is the slope of the given line and a point through which the line passes. Let's assume that the given point is x1 comma y1 and the slope given is m, and let's assume that x comma y is the general point on the line. We have studied earlier that slope can be defined as m is equal to y minus y1 upon x minus x1, where x1 comma y1 and x comma y are any 2 points on the given line. So if I take x minus x1 from the denominator of the right hand side to the numerator of left hand side, I can see that m into x minus x1 equals y minus y1. By rearranging this, y minus y1 equals m into x minus x1. This is the equation of the line in point slope form. For the equation of a line in 2-point form, the required information are the coordinates of the 2 points. Let's assume that the 2 points are x1 comma y1 and x2 comma y2, and let's assume that the general point on this line is x comma y. Writing the slope of the line joining x1 comma y1 and x comma y, this and this point, the slope will be given as y minus y1 upon x minus x1. Now writing the slope of the line joining x1 comma y1 and x2 comma y2, that means this point and this point, you can write the slope is y minus y1 upon x2 minus x1, y2 minus y1 upon x2 minus x1. Now since these 2 lines are the same, we can equate their slopes, and now equating the second expression and the third expression, and taking x minus x1 from the denominator of left hand side to the numerator of right hand side, we can see that y minus y1 equals y2 minus y1 upon x2 minus x1 into x minus x1, and this expression y2 minus y1 upon x2 minus x1 is slope. And if we can compare this and this, we can see that this expression is also the slope. So this is how we define equation of a line in 2-point form. For the equation of a straight line in slope intercept form, we need 2 information. The first one is the slope of the line and the y-intercept that the line makes. So I've drawn a line here, and the y-intercept the line makes is c. So this distance is c, and the slope of the line is m, that is given to us, and x comma y is the general point on the line. We have studied earlier that the slope of a line can be defined as y2 minus y1 upon x2 minus x1, and which is m is equal to y minus c upon x. Taking x to the left hand side, we can see that mx is equal to y minus c. Rearranging this, we can see that y is equal to mx plus c. So this is the required slope intercept form of the straight line. In the double intercept form of the straight line, the required information are the 2 intercepts that the line makes with x and y axis. the intercept made with x-axis is A, and the intercept made with y-axis is B. So this is the line that I have drawn. This is the x-intercept, this is the y-intercept, and this is the general point that I have taken on the line. Now writing the slope of the line joining this point and this point, this is y2 minus y1 upon x2 minus x1, and then this is the slope of the line joining this point and this point, so y2 minus y1 upon x2 minus x1. Now since the line joining these 2 points and these 2 points are the same, so we have equated the slopes, and after equating the second expression and the third expression and rearranging, we see that y upon x minus a is equal to b upon minus a. Now a little more rearrangement will fetch us y upon b equals minus x upon a plus 1, taking x minus x upon a to this side, x by a plus y by b is equal to 1. So this is the equation of the line in 2. So coordinate geometry is one of the easier topics in the JEE syllabus of mathematics, and it has application in some other topics too, like complex numbers. And this is one of those topics in which if a student has done thorough practice and has solved a number of questions, and it is definite that he or she will be able to solve all the questions coming in the examination paper. So this is a topic which is easy and very scoring too. So I think, yeah, that ends my demo class, and thank you.